Okay, the main problem here is to use the substitution x equals e to the t to help us to transform x squared d squared y dx2 minus x dy dx minus 3y equals 0 into a more solvable equation d2y dt squared minus 2 dy dt minus 3y equals 0. Now, the starting point is going to be to differentiate x equals e to the t. Straightforward, dx dt equals e to the t, which of course is x. Self-replicating properties of e to the t. Looking at our differential equation, we need an expression for dy dx involving t's. So the chain rule helps us here. Dy dt times dt dx clearly gives us dy dx. The left-hand side of that product, dy dt, stays with as dy dt, and dt dx, of course, is just the reciprocal of dx dt. So I'll write that as 1 over x. Now comes the more challenging problem. Can we now find an expression for the differential of that? d2y dx2, left-hand side easy. Right-hand side, product. So we're going to have a product. I'll start by differentiating dy dt times 1 over x by leaving dy dt and differentiating 1 over x, clearly, minus 1 over x squared. The second part of the product, leave 1 over x and differentiate dy dt. Now here is the crux of the problem. What do I get when I differentiate with respect to x dy dt? Well, this means we have to take dy dt, differentiate it, and remember we're differentiating with respect to x, so we need to glue on dt dx. So the crux of the problem is when you differentiate dy dt, you differentiate it as a function of t, d2y dt squared, and then glue on dt dx because we're differentiating with respect to x. Okay, so going back to our problem, we now have the product tidied up and we have an extra input. We now know that dt dx is of course 1 over x. So tidying that little bit up, we have minus 1 over x squared dy dt plus indeed 1 over x squared d2y dt squared. That's ready for subbing now. Let's substitute it in our original equation 1. Straightforward. And multiplying through by the x squared, something very beautiful happens. The x squareds disappear, and in the second part of the equation, in fact, the x's disappear as well. And we're left, after a little tidying up, with d2y dt squared minus 2 dy dt minus 3y equals 0. QED, we've arrived at equation 2. And that, of course, is pretty straightforward to solve.